So hi everybody, I'm the last guy for the day, and I'm going to talk to you about Tine, which is a little bit something that's probably very different from the other presentation you saw today, because I'm not really going to talk about the product itself. We're going to talk about the philosophy behind what it is that I try to do. And without further ado, hi, I'm Tim Anglade. I come from France, and I want to start by saying basically an apology because I kind of have a body odor thing going on today. I just want to let people know, if you've talked to me or you're going to talk to me, it's not because I'm French, it's because Delta lost my luggage. So I've been wearing those clothes for 36 hours, and I apologize, really. So sorry about talking to the guys I talked to. Anyway, it's really nice to meet you guys. I spent most of my short career as a freelancer. I did a bunch of things before. I was a research assistant at the University of Maryland. I organized web R&D at a Franco-American web agency, which I quit last month. And these days, I'm mostly freelance gun for hire. I also do 3 other things which have nothing to do with what's at hand. I teach project management at a local university in Paris. I'm an invited expert at the W3C.
Can you speak louder, please?
Sure. Also that. So I'm an invited expert at W3C in the social web group, and I'm CTO of GemKitty, which is a small jewelry startup based in Portland. GemKitty.com, go check it out, because geeks have girlfriends too. I have coupons if you want. Okay, so that's the end of the shameless self-plug. Basically, why am I saying this, though? There's a purpose. I'm saying this because I'm not a data guy. I'm not an IT guy. I'm not even that much of a tech guy, to be honest. I do code. I do like coding. But I came at this problem very much as a hobbyist / amateur / someone just trying to find a solution. So a lot of things might not be very usual in the way I present them, the way I address the problems. Assume it's because I don't know what I'm doing. Really do. I'm here mostly to garner like critiques, commentaries, and whatever you have on Tine and how I can make it better. Last bit. This is the beginning. To the organizers, thanks again, Brad and everybody, for everything. It's kick-ass so far. And another thanks to SteadyCat, which is design, which obviously for the website and bags and everything, obviously influenced me on the slides, so I basically ripped him off on this one. I'm going to talk about sequential data. Sequential data, also sometimes called 1D, one-dimensional data, which is misleading. Sequential data is not data that only has one column in the relational paradigm. It's data that's primarily ordered along one column or one subset of columns. So to give you examples, stocks. For the stock market, there are sequential data. You want them ordered by time all the time. Bank transactions, for the same reason. Sensor data, again, ordered by time, and basically closer to what's popular right now, Twitter feeds and Facebook walls. So that's sequential data. Basically, Tine only works efficiently for sequential data. So I'm working on a very specific subset of programs. Tine probably has way less fields it can be used in when compared to CouchDB or MongoDB, but it tries to do sequential data really well and really efficiently. One reason why sequential data is an interesting field is because while SSDs are coming, we still have a lot of HDDs. Our drives are mechanically optimized to work well with sequential reads, sequential writes, whereas SSDs work really well on random read, random writes. And so it's just a good way of making use of the technology that's there right now. I want to talk a bit about the history of how I came to Tine, just so that you understand, again, the process behind it and how it was constructed. So once upon a time, back in 2007, I was working at a major stock exchange, which I can divulge the name of right now, NASDAQ. And so basically, very kick-ass team, very good infrastructure. It's common fact that most of the companies in that field use Oracle and SQL Server, Microsoft SQL Server. And they really push that thing to the limit. I mean, It was like hardcore. Sharding, partition, views, snapshots, anything you can think of, they were doing it. They had a very efficient set of clusters going on. And basically, even then, you'd have problems on certain stuff. So for example, one thing we were having problem with was giving access to historical data. For historical reasons, data is stored mostly in something that is called, like in the rest of the world, a tape, which is the historical record of every transaction ever happening on the stock market. Those storage I made as a sinkhole. They can write stuff very efficiently, very quickly. They have a million points of data coming in every second. They can write that. But getting the data out, it's not made for that. So even though it's technically an SQL server, it's very much a one-way architecture. Even the cluster that we had that were made to output data didn't work that well. And so basically we're trying to do a new product that would release all the historical data that we had going back to 97. That's 10 years of worth of data at 1 million points per second. That's probably around petabytes very quickly for a year of data. So basically, we're having issues even with all the SQL firepower behind. And back then, 2007, there was no talk about CartoDB and MongoDB and all of those. And so we were trying to find a solution. And we came at it the other way around. We were looking at the cloud, what was there, and there was S3 and EC2, right? Those were the two big things. And so we realized quickly that disk was cheap. In terms of bandwidth, in terms of storage, S3 was a lot cheaper to run permanently as we wanted to do than EC2 was. CPU and RAM were very expensive, which is still the case right now. And so we're like, let's try to find something that works well with those. And we surveyed the whole field. And what we found was that the best approach so far in academic papers was, for this context, to use text and file system. And basically, that came after a lot of research and stuff like that. But it came down to 2 papers, which I completely forgot the reference of. I can't find them anymore. One of them from Switzerland advocated storing stock data, in CSV files. When calling them CSV files, basically they were CSV files. And at the other end of the spectrum, I read something about Philip's research in Eindhoven, doing all its complex systems research on big areas of text files. And so we're like, okay, text and file system. But that felt kind of weird, right? That doesn't really feel like state of the art. We've had like 15 years since, more than that actually, since the file system was devised. And it felt really weird. It felt like, let's go back, let's go forward into the past or something. It was like, felt like a step back, not a step forward. And a lot of people were like, is this going to work? Are we going to get the performance we need? Anything like that. And I was the first one to be dubious about it. Yeah. And so actually it worked. I'm going to take a shortcut into the story and tell you, the final thing we did. And that went like this, was 5 easy steps, right? First step was to output our data to CSV file. So we had one machine that was dedicated to output, and we'd have it write data. So for example, stock data would go 9:32 a.m., the ticker symbol was for Google. We had a asking price of $7.50, bidding price of $6.98, right? You have 2 prices on the stock market for people who don't know, the asking price and the bidding price. So it's fairly simple. We'd output that lines and lines of that. We would take that file, upload it to S3, give it a name that was easily guessable for systems. So ticker symbol, date, for example. And we would just serve it over HTTP. Those URLs don't work, don't try them. Yeah. But anyway, we had ACLs and all that stuff running on top. And so that was basically it, right? So the other side, what was happening, right? The client had to do a bunch of stuff. It had to guess the name of the file. It had to discard the lines it didn't care about, maybe replay a bit of the log, and display the result. And that worked, and that worked pretty efficiently. The client was made in Flex, running inside of Adobe Air, and we could constrain the time it took to serve a single request, because we knew the maximum size of one of those text files. We knew the maximum transfer size, basically guaranteed by S3, and we knew the time it took to calculate and parse the whole file. So we could serve everything well under a second, basically, with that architecture. And so what was left was just counting the bills of the money we had saved, compared to buying a new Oracle or SQL Server cluster. So basically, there comes a slight warning, little one. Some people in the audience might be going like, this is stupid, like as in simple. And I agree completely. I still feel like this is stupidly simple and stupidly obvious so far. The rest, maybe a little bit less so. What I'm going to talk about is going to be a bit more complicated, but still, it's going to be very simple. So why am I here? Basically, I'm here because when I pitched that at NASDAQ, nobody had thought of it. Nobody was doing it. And I still haven't seen many people doing that, instead of just pure research like labs. And so I'm wondering if anybody is doing this, if anybody has tips for doing this better, and basically pitching that because it worked well in NASDAQ, it worked well in a couple other places, and so I'm wondering if we can expand the field and make that like a real category of solutions. Just like we have document-oriented databases, sequential data-oriented databases. So now the rest of my talk is going to be basically talking about the specifics of that approach, the little things you need to pay attention to. And basically, there's a bunch of things. I'm going to cover most of them. The other we can talk about is more like obscure. But it's something you always face when you do text and file systems, databases, and stuff I've tried to address within time. The first thing is shorting. I don't use that word in the same way as MySQL does or SQL solutions do, but it's actually the same idea. The idea is when you split your data. So you do that basically with this approach. You take whatever data input you have. So I'm running the data all with a CSV, but it can come from anything, your data primarily. It can be a sensor, it can be an exist database, whatever you want. And basically you need to figure out how to split that into text files. So this is one approach. As showed earlier, you split by stock, right? And you put one line, Adobe, Amazon, Google, put the data in there. And so you group your data in those files, and the one thing you need to pay attention to is that, remember, this is going to be served directly over HTTP. So this needs to be guessable, logical, and this needs not to be too big. HTTP is very well optimized for like files around 100, 200K. Going above a megabyte, you're going to have a performance hit. Going below 100K, you're going to have a performance hit because of the overhead. So that's one approach. Another approach to split the same content is you split by increments of 10 minutes, for example. And so now you have two files for Google, right? Before, after, because one is at 932 and the other at 943. So that's the basic approach. You need to split those files. You need to basically follow out two laws to split into files and directories, subdirectories. You need to remember the directories are for deletion. I'll explain that later. And you need to remember the two larger files in their redundancy, which also comes from the same thing as deletion, which is caching. So now we basically have this idea of how we prepare the data. The thing is how we query the data. So the idea, obviously, is that you need to skip the middleman, and REST is directly the interface. And I don't mean that as in like you have a RESTful interface, such like CouchDB, right? Which is still a separate API that you need to like learn and adhere to and everything like that. No, it's just REST, your architecture however you want, with directories, subdirectories, and with a bunch of frameworks. So one I like to use is Sinatra. You can overlay dynamic routes on top of static files that are served. So for example, you can serve data at the following URL, stocks.com, Google, 2009, October 29, the one for 9:41 to 9:49 a.m., for 9:41 to 9:49 a.m. That is static file that is prepared. You can overlay shortcuts, Google/today, which you define, for example, as being all the points for the day so far, or /last, which, for example, would be the last 10-minute file. Again, the idea is that you cache this directly, all the requests. And so you get the ability to overlay, dynamic routes on top of static files and serve like the thing as the same. One problem you run into is trying to do range queries, for example. With an SQL language, you get very used to being able to select, for example, according by time. It's very difficult to do in our case. So how do we do that over REST? I like to use HTTP headers. And the one that I like in that is content range. Allow me to do that. So that's what I did at first, but that was kind of cumbersome because it necessitates to use an encoding that has the same length for every character, so either ASCII or UTF-16, and do padding. And you quickly lose space by doing that. And then I discovered section 312 of the RFC for HTTP, which allows you to specify a different unit for content range. And you can define whatever you want. So you can define, for example, a unit day that has subunit to hours and subunit record. And you can work like that and teach your web server to handle those queries and redirect to your app server. Another thing you can try to do is handle query strings. Query strings are fun, except they're very difficult to cache. And if you have common requests, since REST is your only interface, what I do within Tine is that I redirect equivalent queries to one hash, and I cache that hash. Okay? So for example, let's assume here we don't work with stocks. We have Twitter working over Tine, for example. I want all the @replies that Tim sent to Barud. Here's you equate those two queries to this hash, and you store that hash. Again, you need to cache everything. You can blow up, files at a time, directory at a time. It doesn't matter, and you can do that very, very efficiently. The idea again works for caching. Works also in query strings. Works with the hash and URLs. If you only want to specify a starting point, I'll show you an example on that in the next section. One mode that is specific is kind of a degraded mode of functioning. For Tine is triage mode, which is basically the same idea as hospital in time of crisis. Everybody goes to the same place, and you just do basic care, and you get rid of queries very, very fast. So one idea, for example, is that I get the following query, ask me for my Twitter feed starting at 3:20 p.m. Normally, I would do that on my own by parsing the file I have and only sending back whatever is after 3:20, calculated on the server side. In triage mode, I just send the file and let the client parse. The idea is that the clients need to be aware that this can happen and handle it accordingly. Another functionality you can have is offsetting, very useful in triage mode also. The thing is that if most people have noticed that we learned this the hard way working on the general version of Tine, that if people have any kind of direct input on your database, they're going to tend to request even times. So usually that's not a big problem, but let's assume, for example, you have your Twitter feeds, and somebody requests all this messages I posted between 9 and 9:30 a.m. This would be fine for Twitter because you know that kind of range, and that feels logical. But you have to pay attention to it if you're doing stocks. Because what happens in stocks, people work in a very different way. The most often what they want to do is check the execution of one of their trades. So what happens is that they know their trade executed somewhere around 9 a.m. They're going to enter 9 a.m., but they don't know if it was just before or just after 9 a.m. So if you store your data, split your data, shard your data according to even hours, you're going to have to concatenate files all the time. Whereas if you offset them, for example, by 10 minutes, you're going to be able to serve a single file, which is tremendous help in triage mode and in any kind of calculation. The last functionality that I try to put in Tine is the ability to do operations on the data. And basically it's something that we don't even realize, but we have with SQL as a language. We have the ability to select a minimum, maximum, the average, count records, stuff like that, which are basically a transformation of the data. And I try to put that in not because SQL had it, but because I had an opposite problem. My problem is that trying to work with REST is that REST is not plug and play at all. Being RESTful doesn't mean much because it's still a bear to integrate. You have to go through the documentation, learn how to parse the XML, use that for hours, and it's a very, very complex system. So what I was trying to do is have a way to conform any REST resource to my needs. What I wanted to do is that give the ability to upload something to tell them to serve me the data in a certain way. So for example, I was hitting a REST API for temperatures, and I was getting back temperatures in Fahrenheit. And as a Frenchman, I want temperature in Celsius. And I was kind of bored of having to do that all the time and convert. So I wanted to have like open systems that allowed people to specify how they wanted the data sent back. So what I did is that I did very simple file at first. So this is like a YML file with like an ERB template thrown over it. And the idea is that it's fill in the blanks, right? I want the data sent back as this. You take your reading, which was stored as T, and you give me the aggregate over like the collection. And on the other end, just for simple conversion to Celsius, it would be the second one. I would like send me the place and do the conversion, send me that back. What I discovered recently is that there was a much more efficient way to do this, which is referred to as BX, which is either bidirectional transformation or bijective transformation. It's a very kind of new field, mostly because people have been working on this from separate angles from a long time, and only discovered that in mathematics, physics, data, systems, IT, they were all looking at the same thing from a different angle and with a different vocabulary and different name. Right now what you have is you have a whole set of syntaxes that allow you to transform data like that on the fly. Specify like a language like XQuery, which pass, what to select, what to transform. And what the field has even come up with is languages where you can write a transformation once, and it works both ways. You can do the transformation and do the reverse of the transformation, which is very useful to go back and forth in your data. And so right now, it's kind of like the road ahead. I'm trying to implement that into time under the name of Lances. The idea being that let people like upload code basically that I know will not corrupt or access my file system, will only specify transformations on existing data, and be able to go back and forth between those states of the data, so that I can serve directly what they need, and they don't have to parse that much, or they don't have to do like stupid transformation like Fahrenheit to Celsius. You can go even deeper than that. Again, averages, minimum, maximum, this kind of stuff. And the other thing I'm trying to do for Tine is put up more code. I have a GitHub account set up, which was linked on NoSQLEast. Basically, the idea is that a lot of the code I did originally while at that stock exchange, I'm not allowed to reuse that code. Since most of what I did there was a very boring, low-level file access, file splitting code, I'm not really in a hurry to recode this, kind of like what Cliff was going through. And so I'm trying to find either an issue with them about that, or rewrite it probably better than I did originally. So anyway, this is basically the approach. Since it's kind of like different and totally unknown, I let a lot of time for Q&A. Hopefully answers, and anything you have on the subject.
Can I kick it off and maybe you can just repeat it?
Yeah.
So very cool. What was the sustained data rate on this uncompressed data? Is it around a gigabyte per second, or is it 10x that?
For what?
The stock data.
Oh, the stock data? Basically, what happens is that.
Dan, can you repeat the question?
Oh, the question. Sorry. Yeah, the question was the rate we would get. Incoming data was coming in probably at a maximum of 10 points per millisecond. Usually between 1 and 10 points per millisecond. So you aggregate that to a lot. Basically, a line was fairly long. A line was around 150 bytes. Because you had stock, you had the origin code, destination code, you had a bunch of stuff to remember. So yeah, sustained rate was incoming. You can do the calculation, I can't remember, but yeah, it's very quickly around a gigabyte a second. Especially since now you have to aggregate like data on all the exchanges across the US. Yeah.
So I have my own question. How close are you to pushing to GitHub?
Basically, I'm close enough to pushing. What I'm trying to figure out is, and I guess that's a good question to ask of the audience, whether people want to see an example or people want to like be able to reproduce the approach or reuse. The idea, as you saw, is that the approach you have to use to reproduce something at a time is very closely linked to the kind of data you have. And I find that there is not much that you could reuse. If I put up an example geared for stock data, you could very easily inspire yourself from it, but you could not reuse it unless you were trying to do stock data. If I want to do like a Twitter clone, it would be the same thing. And so my question in much of the angling was being like, okay, do I need to just reproduce, like do an example, or do I need to put up documentation more than code? And I have no idea what is really kind of like the intended use people would have. Or maybe like there is like one very like broad emerging theme that the audience would have, a case study they would like to see, in which I would be more than happy to build that as the first release. News feeds, RSS, yeah.
Not just RSS, more especially press, all those things, they send information.
Mm-hmm. Yeah, I see the use case. Right.
And it is time sensitive.
It is time sensitive. It is time ordered, yeah, which is useful.
Plus one for documentation.
What? Plus one for documentation, yeah.
I'd say we need both, documentation and examples. And kind of one of the use cases might be like collectee monitoring and getting a lot of information about each machine and then shoving it off to some central server and then being able to view graphs.
Oh, you meant like logs, for example?
Not the text logs, but the performance logs.
Performance logs, okay. No, yeah, I think like a lot of the approach obviously are a mix between stuff that's been used for log data, the way you shard log data and the way you store and parse log data, and build on top of that. So it's a very natural use case, yeah.
But then I guess the question is, you haven't shown any examples of aggregation.
Okay, the idea behind the aggregation is that people know how to write to a text file. And there is a system of logs in place on text files. And so I kind of leave that up to people to ingest like the data however they want. I feel that most programs, most databases existing, whatever, kind of put to CSV, for example, which is a very nice starting point for your data. So usually, I never considered like really going to this because it's a very different system. It could be a separate program, and you would like the system wouldn't know about it.
Well, I'm talking about aggregation over multiple days.
Okay. The idea is just concatenation. Basically, it's just that one thing you can do, and in one part I skipped, actually removed from the slides to keep time for questions, was the whole core of aggregation. And for example, indexes, or something to replace indexes, is that you introduce data redundancy very quickly, and not the good kind of data redundancy. Really the bad kind of data redundancy. So for example, I was looking at redoing the whole Twitter search, everything like that, with a system like Time. And the idea is that you would need to have a set of data, for example, by user, by time. That would be one set of files. And then you would have another set of files which would be just by time, aggregate all users. You would have another one which would just be like direct messages from this person to this person by time, et cetera, et cetera, et cetera. And obviously you can construct that with a system of links to like try to prevent redundancy, but you have to keep checking like the links are still valid. Or you would have to just be able to kind of keep track of that. I tried a few solutions like signatures and whatever to be able to go back to a file and change. The fact is that it's not something you want to get into, which again is why I try to be like single order sequential data. We kind of remove like a lot of the aggregation. So basically, if you cannot like write the aggregated file yourself, it's probably like not worth using something like Time. But again, the idea is that you don't have that many files, that many problems that require like complex aggregation like this. For example, you have a lot of systems which are one-way aggregations, like the Facebook walls. Facebook walls are aggregated, but it just blows the cache up and redo a new file. And it has a very short expiry time. So basically, you could use something like Time because it will blow up before anything happens, and people assume it is cached. The other thing would be Twitter. Twitter doesn't allow you to edit a message. You can only delete. And that's something that's fairly easy to do. And that was one of the things I was referring to in the slides before. The idea is that ideally you have directories you can blow up very easily for caching, but also that you have a single point per file. That's what you try to tend to with a system like that, because then you can just grab the file, delete it. You don't need to open a file and go look into it, and you gain a lot of time. The problem being that the more files you have, the more I/O you have to do, and blah, blah, blah. So it's always about finding some way to balance those two out while staying between 100 and 1 meg in size. Oop.
Cliffendor.
Just one question. What font is that?
That's Aller.
I'm sorry, what?
A-L-L-E-R. And yeah, Steadycat used it at first, but it's not, you can't embed it on the web, so. Cool. Well, thank you very much.